I've been fortunate enough to travel to a few glaciers myself to kind of get that first-hand look at how our glaciers are melting and our glaciers are retreating. And they're going quickly, even though we are in a period of interglaciation, meaning a non-ice age. We're seeing very quick melting, faster than we should. The first glacier here is Exit Glacier in Kenai Fjords National Park in southern Alaska. And my son David and I got the opportunity to go there a few years back. And when you walk along the path, you get to the national park and you walk along the path to see the Exit Glacier. They actually have signs that show you where the glacier was over time. So this picture here shows you where the glacier was in the year 1917. So this is where it was. You can actually see the glacier kind of far off, tucked in the valley there. Now, as the glacier's been receding, it's been pulling back, and you can go along this walk to see the various points that the glacier is receding. So David and I are walking up the path towards the glacier, and this next is a little stop here is 1926. We're almost to the outwash plain. But you got to think, almost 100 years ago, the glacier was at this point. So as we're walking up, you can start to see the outwash plain and the river there out to the left-hand side, and we're getting closer and closer to the glacier. So now we're getting closer to the outwash plain. We're getting to a sign that shows where the glacier was in 1951. So you turn the corner, and you get a better view of the outwash plain and where the Exit Glacier is currently. So the distance you're seeing here is probably about 1/4 of a mile-ish. And that's the outwash plain, which is crazy because when David and I were standing there, we actually saw chunks of ice flowing down in the outwash plain from the glacier. So the Exit Glacier has a beautiful medial moraine coming right down the middle. You can see that. But this glacier is retreating very, very, very quickly. This is actually a better panorama of the whole entire outwash plain there. So you can actually see how big this outwash plain is. There's the Exit Glacier there, and now we're panning over to the left side there, and you can see. And like I said, David and I saw chunks of glacier ice flowing down through that outwash plain. And this glacier is retreating very quickly, and this chart here shows the extent of the glacier over time. So you can see where it was all the way back in 1950 and where it is today. So moving down to the lower 48 here, we got Glacier National Park. And this is just one of my favorite pictures that we took on our family trip. This is Lake Sherburne right here. We're looking up the valley. And you can actually see many U-shaped valleys and cirques. I've shown you this picture before. Now, kind of in the middle to the middle left there is the Grinnell Glacier, which is actually one of the few remaining glaciers in Glacier National Park. This is one they've been charting out and mapping and following for a while. And here is a little more zoomed in picture here. As we're getting closer, we're actually hiking around some of the lakes up near Grinnell Glacier. You can see Grinnell Glacier a little more centered in that photo. And then we went up a little bit further up to get a better view of Grinnell Glacier there. And you can see it up on top of that little ice or that cliff up there. Now, that's all that's left. It's not growing. It is receding. This is one of those glaciers that they're saying could be gone within the next 10 to 20 years in Glacier National Park. And, they may have to change it the name to Glacier List now. That's why I wanted to get up there and see these glaciers. It is a phenomenal national park, just seeing the glaciers that are there. These are all alpine glaciers because they are locked up in the mountains. Like I was saying, Grinnell Glacier is one of the fast retreating glaciers in Glacier National Park. And this sign here at the park actually shows how the glaciers have been changing. So you have the first picture there in 1938. You can see there's no lake there. There's no tarn visible in that picture. And you can see all the moraines and things like that. But as time has gone on, you can see 1981, 1998, 2009, 2013, the glacier's been retreating and that lake is getting larger, and you have these calving events where the ice is breaking. And alpine glaciers don't calve. The calving is where the front of the glacier or part of the glacier comes off is usually done with tidewater glaciers. So you can see right there over time how this glacier has been changing. And they've been studying and measuring this glacier since the late 1800s. Now, Glacier National Park does have a few other glaciers. This is two of them right here. Now, originally, this glacier was actually one glacier, the Blackfoot Glacier. But as the planet started to warm and the glaciers began to retreat, we actually saw another glacier emerge out of here. And now we have the Jackson Glacier and the Blackfoot Glacier here. And you can actually see kind of the evidence of those two glaciers flowing down into that valley. Now, originally, you just had one massive glacier, the Blackfoot. But as the glacier has been retreating, it allowed for the Jackson Glacier to be more visible and more present. All right, so let's jump out of the country here. Let's check out some glaciers in Iceland. This image here is a glacier in Vatnajökull, which is a large ice sheet in Iceland, and glaciers flow off of it. You can see the top picture there is from 1925, and you can see the end of the glacier there at the beginning of the end moraine and the outwash plain. And now the bottom picture there is 2012. Completely different. The glacier has gone through massive retreating. Now this picture here is another glacier that comes off of Vatnajökull, and you can see the picture in 1925. And you can see how much the glaciers changed from 1925 to 2012. So again, these glaciers are rapidly retreating. And you see the picture there from 1912. And then this picture here is a picture that I actually took in our last student trip to Iceland in 2019. And you can even see just from 2012 to 2019, even some retreat. So Iceland has some of the fastest retreating glaciers in the world. You know, people who live in Iceland, they're really in tune with their environment. And they do take a lot of pictures of their environment, and they have a lot of good record of how their environment's changed. And again, here's another shot of those Vatnajökull glaciers, 1925 to 2012. And you see that terminus right there in 1925 and 1912. It's pretty much gone all the way up into the mountain. So these glaciers are retreating. And I've been there quite a few times, and since I've been going there, I have also seen those changes in Iceland's glaciers. One of the glaciers they showcased in the movie Chasing Ice is the Solheimjökull Glacier in Iceland. And this is a picture that I took in 2013 of the Solheimjökull Glacier. And in 2014, we went back, and there was change. In 2013, when we hiked on this glacier, we were able to walk up the face of it. In 2014, we had to hike around the side because the front of it had become so unstable, and they had large calving events. But even just between 2013 and 2014, you could see some of that change. Here's a picture that I took in 2013 from on top of the glacier looking down. And you can see the glacial lake at the front of the glacier. Now comparing the picture from 2013 to a picture I took in 2015 from the top of the glacier, you can see a large amount of change in that outwash plain. You look at that lake that had formed at the toe of the glacier. In 2013, there was a lot of sediment buildup and things of that sort. But in 2015, a lot of that sediment had been washed away because of the glacier melting and retreating. And for me, the next picture here is the biggest change I think I've ever seen. This is Svínafellsjökull in Iceland, also known as in our group as Matt Damon Jökull. This is actually where part of the movie Interstellar was formed. So kind of a fun fact there. But the bottom picture you see there is from our trip in 2015. And then the top picture, taken at the exact same location, is a picture I took in 2019. So you can just see how much of that glacier has broken off, has melted. You can see how much of that sediment's been washed away because of the warming environment in Iceland and the climate change. It's changing the glaciers in Iceland. So the last group of photos and videos I want to show you all are from my trek to Everest Base Camp. The Khumbu Glacier is the dominant glacier in that area. It's actually where Everest Base Camp is. And this right here actually shows you kind of how it's changed over time. The little black and white photo there is from the late 1950s, and the bottom one is from 2007. And they can see how much that glacier's changed because there's a lot of debris and sediment on top of it. There's not a whole lot of new ice forming. It's a lot more sediment as the glacier melts. The sediment that the glacier eroded from the mountains is becoming more present. You can see here in this photo that I took, I'm actually on the lateral moraine of the Khumbu Glacier looking down at the glacier. And you can see the pools of glacial meltwater. You can see little pieces of glacier kind of shining out through the ice, but a lot of it's just sediment. Now this next photo here is a little bit further up the Khumbu Glacier, and you can see the glacier. It's a panorama. We're looking down towards the end of the glacier, all the way up into the Himalayas, towards Mount Everest and Everest Base Camp of the glacier. And you can see I'm standing again on the lateral moraine. You can look across the glacier to the other side where the lateral moraine is, and there's that light gray line up there, and that's actually where the glacier used to be. The glacier carved out this valley, and you had those other alpine glaciers that were forming or that were flowing from those mountains down into the Khumbu Glacier. Now we're at about 16,000, 17,000 feet here, so that just tells you how high those peaks are. Those peaks are 20 plus thousand feet. So this area is drastically changing because of climate change. The glaciers are retreating very quickly. And you have all that sediment left on top of the glaciers. You know, for me, this picture here says a lot. We're here at the heart of where Everest Base Camp is. Now we're there at the beginning of June, so a lot of the treks have left. But right there you see the main stupa. Stupa is like a place where you go to pray, and this is where a lot of the people who are going to climb Everest ask the gods if they have permission to climb. So this is right here, like I said, in the heart of base camp. But you're looking at the lateral moraine of the Khumbu Glacier. We're standing on the Khumbu Glacier. Even though it doesn't look like the glacier, it's because it's covered in debris. All that debris came from further up when the glacier was much thicker and more prominent. As the glacier would advance and retreat, it would carve out the Himalayas, and this material was suspended in the glacier. Well, as the glaciers retreated and melted, it's deposited all this material. And some of this material also came up from some of those other alpine glaciers. Like you can see, there's a good one there up on the upper left. So all those glaciers flowed into the Khumbu Glacier, and the Khumbu Glacier eroded out. But because all these glaciers are retreating, now we're just seeing all of this rubble. And you can see how tall the Khumbu Glacier used to be. And it's quickly retreating. And like I said before, they're having to relocate base camp because the glacier is getting getting unstable. They're seeing more avalanches because of the warming temperatures. So it's just really interesting to see how this area is being affected by climate change. You can see the glacier melting. All of base camp at Mount Everest is actually on the Khumbu Glacier. They've had to move base camp because the glacier keeps retreating. You just see the ice fall and melt. It's a really warm day. No wind. So this last little video here is video that I took from a helicopter. My buddy Eric and I got a helicopter from just outside of Everest Base Camp to take us back down to Lukla. I wanted to actually take this helicopter flight for the purpose of showing you all the glacial features. So we're actually going to go down the Khumbu Glacier, and you'll be able to see the moraines, the lateral moraines. You'll be able to see the sediment on top of the glacier. So here we go. So we're flying now. We're over the lateral moraine, and now we're dipping down into the Khumbu Glacier, which is crazy because when you look at it, this gives you a different view of where the glacier is now and where it used to be. So think about, we're down in the glacier now, and you can see off to the right there how tall that lateral moraine is. So all that right there is sediment that was brought down by glaciation within the Himalayas from those other alpine glaciers, also from the Khumbu Glacier higher up as it eroded out the valley there. So you can see just there's glacier down there. You can see the helicopter's shadow. There's glacier, there's ice down there, but it's also covered by a pretty big layer of glacial sediment. You just look at how massive and dominant these mountains are. I mean, the Himalayas are a newly forming mountain range. Mountains that are steep and like that, very, very jagged, are relatively young mountains. Mountains that are more rounded are older mountains. You can look up that valley right there. Got a nice U-shaped valley. You can see that where the glacier had been and now is retreating up into the mountain. See some of those lakes down there. You can actually see some of the Khumbu Glacier as we're flying over it. So when we were there, you could actually hear the glacier snapping and popping. We could hear that in some of the glaciers in Alaska and Iceland. Glaciers are just a great example of active geology. And here you see some of those meltwater lakes, which is on top of the ice. There's ice down there. And those lakes and that sediment is on top of the ice. So here we are now leaving. You can see the end or terminal moraine of the Khumbu Glacier here. And we dip down into the next U-shaped valley. So that's the end of the Khumbu Glacier. And you can see the outwash plain there coming down from the Khumbu Glacier. I do want to leave you with this. Traveling around the world and seeing glaciers and how glaciers are changing definitely makes this idea of a global climate real. We are going through a natural interglacial period, meaning our planet is naturally warming. And we will go back into another ice age. Our planet goes through these cycles. Ice core data shows us that. And here's a picture of that ice core data. We go to Antarctica, we take out these large ice cores. We go to Greenland, we look at these large ice cores, and we can see how our climate has changed in the ice cores because we can measure our atmosphere from these ice cores. Ice cores are just samples of the atmosphere from that time period because the air gets trapped in the ice. And we notice that when there's more CO2 in the atmosphere, our planet's warmer. When there's less CO2 in the atmosphere, our planet is cooler. And right now we're seeing an increase in CO2, so our planet would be warmer. The thing that has a lot of climatologists a little nervous is the rate of CO2 increase. So even though we are in a natural global warming or interglacial period, we've never seen an increase of CO2, an exponential curve like that in CO2 before in ice core data. So we know that while Earth is going on a natural interglacial warming period, humans do have an effect on that because of our release of CO2 since the Industrial Revolution. The big question among scientists isn't if global warming or climate change or global cooling is real. The big debate among scientists is how much of an impact do humans have? We know we have an impact, but how much of an impact do humans have? This is something we haven't measured before. So by seeing this rate of increase of CO2 and seeing a larger rate of glacial melt, who knows what's in store? But the data is definitely showing and pointing to a warming planet. What's going on, Geology? Mr. Mack here. Here with David. We're out here being socially distant. I think we're 6 feet away. Just enjoying the weather here, but also trying not to be trapped inside. But I also wanted to bring y'all up here because this is one of my favorite views. And this is a view you actually can see pretty much every day. You right here, this is Monarch. So we're in the ranch, all right? Highlands Ranch High School's down there. And right out there are mountains that have been carved out by glaciation. So every day you're looking at these mountains. So right out there you have Mount Evans and this little dip over to Mount Spalding. Mount Evans is 14,000 feet, Mount Spalding is 13. And they're both carved out by glaciation. Matter of fact, that little ridge between Mount Evans and Mount Spalding is what we call an arête. You have a little dip in there, a col, which is a wind-blown glacial feature. And it formed a cirque at the very top. And up there at Summit Lake, if you've ever been up there, is where that lake was formed by glaciation. We call that a tarn. But, Darn it, you probably already knew that. Sorry. All right. So the glaciers formed down there. You can actually see the whole U-shaped valley there. As the glaciers carved out the mountains, it formed that U-shaped valley. Now where the kind of rocks get a little jagged and it goes from being snowy to not snowy, you actually have a hanging valley there. It's kind of hard to see, but it's there. And you also have on the other side of the ridge some lakes that are connected by rivers that have been carved out by glaciation. Those are called paternoster lakes. Now if we come down here a little bit, we have another area of mountains that have been uplifted. Make sure you're being uplifting today. See, I can still do it even though we're not in class. But those, we got some motorcycles coming. It's gonna be a little noisy. But we'll wait for the motorcycles to pass. Woo! All right, so, more cars. And those mountains right there, you can actually see them. Also formed and carved out by glaciers. You actually have 1, 2, 3 U-shaped valleys. And at the upper part of those U-shaped valleys in the accumulation zone is where you have your cirque. The snow accumulates in the mountains, becomes a glacier, and as that glacier flows down from the cirque, it carves out those U-shaped valleys. Now, one little more area that I wanted to show you is, David, maybe if you come over here, we might be able to get it. I don't know. But over by that rock cliff there is a mountain way out in the distance. That's Long's Peak. Long's Peak is in Rocky Mountain National Park. So actually what's really nice is that cliff right there shows some really good strata, all sedimentary layers right here in Douglas County. But again, out in the distance is Long's Peak. Long's Peak is an example of what we call a horn. A horn is a mountain that's carved out by glaciers on all sides. So you have a glacier here, glacier here, glacier here, and then you have this really steep mountain. The Matterhorn in Switzerland is a really good example of that. So I'm gonna throw in some pictures from other glaciers that I've visited to show you other glacial features after my little video here. Hope you guys are having a great day. Boom!